everyone. So myself, I am Uttaramu, Assistant Professor, working as Department of Civil Engineering at PSN College of Engineering and Technology. So in this lecture, we have to discuss about the subject of structural analysis. So we are analyzing the beam or column. So the lot of method is there. So here we are discuss about strain energy method. So what is strain energy? So here the strain energy is nothing but if the sum of the energy is stored and then we have to release. So that is simply we have to say the energy stored by a member which it will be take some work done by the some external force. So it is which is not exceed the elastic limit. So is known as the strain energy. For example, for strain energy, so in this picture we know the strain energy. So for example, if you are consider the first picture, we will give the full force, and second picture we have to release the force. So here if the energy it will be the released which is the not exceeding the elastic limit. So that is called as the strain energy. So this is the general formula we have to use it for this strain energy method. If the force is gradually applied, you have to use the U is equal to half by B into del. Here the U represent as the strain energy notations and P represent as the given load, that is the external load. The del is represented as the changing of the length. For externally axial load member, we call as a U is equal to P squared L divided by 2 into AE. For strain energy formula, we have to use the U is equal to integral 1 divided by U divided by 2EI into dx. So that is the general formula we have to use it for the strain energy. So here we have to discuss for one continuous beam, analyze the beam by strain energy method. So in this picture we have the two simply supported A and C. Here we are consider this beam having a two span, that is the span AB and the span BC. Okay, so which a load of the 10 kilonewton and 10 kilonewton with the distance of A to B 10 meter and B to C also 10 meter. So we have to analyze the beam by strain energy method. So before going to solve the problem, so we have to know the how many reactions for this beam. So there is a three reactions, that is here one reactions RA and RB and RC. So these are the reactions. So we have the number of unknown reaction and moments if there is the moment. So that is the three reactions. So RA, RB and RC. Now what are the equilibrium equations available for this problem? That is the two equations, that is moment, that is sum of moment, and the second one is sum of the vertical force. Here there is no horizontal forces. So next we have to find the static indeterminacy. Here the static indeterminacy is equal to number of unknown reactions minus number of available equations. So that is 3 minus 2 which is equal to 1. So we have to consider the redundant force for the support of RA. So we are considering the redundant force for the RA. So here the span is we are splitted into the two section. So here the RA is a one section and here also we are considered as the second section. So the first section is A to D and second section is DB. So here the distance is x. Here also we represent as the x distance. Now we are using the strain energy due to the bending, which is U is equal to 1 divided by 2EI integration of m squared into dx. So this is for the strain energy equation for the bending sections. So why we are called as a bending section? If you are applied the load, the beam will be deflected. So it will be the some bending. So we can finding the bending equations. So the formula for the bending equation, U is equal to 1 divided by 2a integration of m squared into dx. Here they are having the two sections. So here what are the two sections? A and D is the one section and DB is the second section. So we have to split it in this two section in this formula. So here the beam is symmetrically as well as if the load acting also the symmetrically. So we are taking the one section. Okay, so we are adding the 2 into 1 divided by EI integration of 0 to 5. Here 0 to 5 means here 0, here that distance is 5. So we are putting the 0 to 5. for the M1 section. Here the M1 represents as the moment at the section 1. So we are called as a M1 d squared dx plus, and second section 2 into 1 divided by 2a integration of here 5 to here 10. So we put the limit 5 to 10 which is into m2 d squared into dx. Here the t1 and 2 represent as a section 1 and section 2. So we are put it into the 1 and 2. Now we are simplify the equations. We are getting this u is equal to 1 divided by ei 0 to 5 m1 d squared dx plus 1 divided by ei integral 5 to 10 m2 squared into dx. So here the 2 is cancelled. So in this equation here also the 2 it will be cancelled. So 1 divided by ei integral 0 to 5 m1 squared dx plus 1 divided by ei integral 5 to 10 m2 squared into dx. So next we have to finding the equation. So what is the m value, and we have to finding the m1 value and m2 value. So we are applying the right side equations, that is a right hand signs. So it is the clockwise direction we are considered as a positive. If we are acting the force anti-clockwise, we are considering as a negative sign. So that is a RH sign. So now we are considering the section here X for the section AD and the section BD. So first we are taking moment about for the section A. So moment about for the section A. So here M1 we can find the M1 distance. So what is the reaction R1 is the distance is X. So M1 is equal to RA into X. Again you are partially differential equation with respect to RA. So dou M1 divided by dou RA which is equal to A. Here the RA value is equal to 1. That is we are consider the RA is equal to return force. So here put it into the 1. So that is 1 into X, that is X. So this is for the dou M1 divided by dou RA. So this is value for the M1 is equal to RA into X. Next we can find the M2 value. So here we are considering the section B and D. So we are considering section B and D. So the same equation we are considering for this section. So here we are considering the limit 1 divided by ei integral 5 to 10 m2 d squared into dx. So we are taking moment about point A. So we are taking moment about point A. So here finding the m2 distance. So here the distance is RA. So here the load acting on the RA. So RA into the distance is X. Next we are considering the point 10. It is the anti-clockwise movement about the point B. So we are considering the negative sign. So 10 into here the distance is X. So the distance is acting here to here. We know the distance, total distance here to here is 5. So x minus 5. So we are simplify the equation RA into x. So we can multiply by the 10. So 10x, then 10 into 5, that is a 50. Next again it is partial differential equation by the RA. So dou m2 divided by dou RA which is equal to x. Equal to x. Here we are considering the return force 1. Here there is no RA, so it is the 0. So that is dou m2 divided by dou RA is equal to x. So now the strain energy formula U is equal to 1 divided by ei 0 to 5 m1 squared dx plus 1 divided by ei 0 to 5 to 10 m2 squared into dx. So we know the value of m1, dou m1 divided by dou RA, and m2 value and dou m2 divided by dou RA. So we know the every value. So you can substitute this all the values in these equations. So by this equation we are using the Castiglione's theorem. So it is we are partially differentiate with respect to the RA. So here dou U divided by dou RA is equal to 0. That is dou divided by dou RA is equal to 1 divided by ei 0 to 5 2 m1. That is here the partially differential equation, that is 2m1. Again here note the m. So we can again it is partially differentiate with respect to a. So dou m1 divided by dou RA into dx plus consider this section 1 divided by ei integral 5 to 10. Again it is equation integrated by m, that is 2m2 dou m2 divided by dou a into dx. So this is the equation. Now we are substitute this m1 value and m1 divided by r1 value, next substitute the m2 value, next substitute the m2 divided by ra value. So in this equation you are consider this procedure. So here we are taking the outside dou a divided by dou ra. So here the 1 divided by ei, here also 1 divided by ea. So take it outside. So here 0 into ei divided by 2. Here also 1 2, here also 1 2. So we are taking in outside 1 divided by ei into 2. So ei divided by 2, it will be the 0. So 0 into every term it will be the 0. So that is what is the final equation. Here integral 0 to 5 dou 1 m1 dou ra dx plus integral 5 to 10 m2 dou m2 dou ra into dx is equal to 0. Now we are substitute the m1 value, dou m1 divided by ra value. Similarly m2 and dou m2 divided by dou ra value. So what is the value of m1? We know the value of m1 ra into x. So here we are substitute. Next dou m1 divided by dou ra. So here the x. So x into dx plus integral 5 to 10 ra plus ra into x minus here the m2 value is ra into x minus 10x plus 50. So we substitute the value of m2 value, and m2 divided by r2a value is x. So here x into dx is equal to 0. Now we are simplifying this equation. So in this equation we are multiplying the equation, that is we are substituting the value ra into x and x squared into dx plus integral 5 to 10. We are substituting the value here the ra into x squared minus 10x squared plus 550x into dx, which is equal to 0. Next, so this is the final equation. Now we are applying this equation, integration of x power n into dx. In this equation we have to apply for this equation. So we know the value of integration x power n dx. What is the formula? X power n plus 1 divided by n plus 1. So from this equation you have to integrate this. So integration into ra. Here the integration of x squared is equal to x cubed by 3, limit 0 to 5. Plus ra into here the x squared integration x cubed divided by 3, limit 5 to 10, minus here the value is x cubed divided by 3 integral 5 to 10 plus here the 50 x squared, here integration of x squared divided by 2, that is 5, limit for the 5 to 10 which is equal to 0. So here only we are applying the upper limit for this section. So here the lower limit is 0. So for this section we have to apply this upper limit. So that is the ra divided by 3, power of 5 is equal to 125 plus ra by 3, the power of 10 is equal to 875 minus 10. So that is we are simply added this sections. So 10 into the power of 10, so 8750 divided by 3 plus remaining section. So we are getting the, from this equation we are getting the ra value. So we know the value of equal to, so this is the ra. So for the section ra, this support is called as a rc. So it is a symmetric section. So we have to consider for the ra is equal to rc, which is equal to 3.125 kilonewton. Why we are taking rc is equal to ra is equal to same value? So this is for the symmetric section. So we have to consider for the one section, that is span of a b sections, that is a span spin only we are consider. Why? So this is the symmetric section. So next we know the value of ra and rc. So now we are going to finding the rp value. Now we are applying the equilibrium conditions, that is summation v is equal to 0, that is sum of vertical force is equal to 0. So here the sum of vertical forces, here ra 1 vertical forces and rb 1 vertical forces and rc 1 vertical forces and 2 loads, that is 10 kilonewton, here also 10 kilonewton. So summation of v is equal to 0. So the first vertical force 3.125 plus, that is here the upward is positive, so we are considering the plus sign. If the force acting downward means it is the anti-clockwise, so we are consider for the sign of minus. So here the positive, here the rb is also positive. Now the rc value is positive, that is the 3 values are the upward direction. Now we are considering the 10 kilonewton, so it is a negative sign, so put it into minus. Here also 10, so we are put it into the minus. So from the equation we are getting the RB value, that is 13.75 kilonewton. Okay, next we are finding the moment, so that is the moment for the B at the point B sections. So we are taking moment about point B. So we are considering, so it is here also we are using the RH sign, so the right hand side sign we are considering. So if the force acting clockwise is the positive, if the force acting negative sign means we are considering the negative, anti-clockwise means we are considering the negative sign. So here if the load acting is the positive sign, so here the positive sign about the point B, so that is 3.125 in the total distance is 10. Okay, next in this sign it is the anti-clockwise movement about the point B. So about the point B it is the anti-clockwise movement, so minus 10 into this distance 5 plus here the we are considering the one moment, so we are considering the positive sign, so it is a hacking of moment, so we are considering taking the positive moment MP is equal to 0. From this equation we are getting the MP values, that is a moment at point B, so that is MP is equal to 18.75 kilonewton per meter. Okay, so now we are finding the free end moment. So from this equation we are finding the free end moment, that is WL divided by 4. Here the W considered as the load for the section 10 into the distance is total for the consider the span of A to B. So here the distance is 10. So 10 into 10 divided by 4, which is equal to 25 kilonewton per meter. So it is for the free end diagram. So here also 25, here also the 25. Okay, so here the one support is, here also one support RA, here support RB, here support RC. So that, so only for this here to here the load will be acted. So it is the free end moment diagram. Now we are finding the ending moment diagram. So here the ending moment diagram, it is the we know the value for the MB, that is the 18.5. so it is the hacking of the moment, so we are considered as the 18.75 is the negative sign. Now we are considering this two diagram, that is the free end moment diagram and the end moment diagram. So we are getting the moment diagram, so combined this diagrams, so that is we are getting the end moment diagrams. We are finding getting the bending moment diagram for this section. So this is the picture. So we are considering this picture, combine this picture. Here the picture is 18.75. Okay, so this is for the shear force diagram for this section. So we know the RA value, we know the RB value, and also we know the RC value. Here the RA and RC value is the same. Now we are taking shear force for that point left side, that is a clockwise movement, so we are considering the positive. From the R to D point we are considering as a 3.15. Next is the load acting the 10, so that is the 10 minus 3.125, we are getting the 675, that is a minus sign. So it is also anti-clockwise movement, so we are getting the minus sign. Again it is a positive, so the same value is same, here also the same. So this is for the shear force diagram for this section for the beam. Okay, in this above case we are finding the moment for the different sections. So we are finding the moment for the A and C, so it is a 0 because it is the simply supported, so the end bending moment it will be the 0, A and C. Next bending moment at D and E, so we are considering the bending moment at D and bending moment at E. So the same procedure we have to apply this for the point D and E. So we are getting the value of D and E. So once if we are getting the point D, so it is equal to the E point because it is the symmetric section. So we are applying this for the same value. Next is the bending moment at point B, so minus, so this is the final bending moment diagram for this beam. So this is for the continuous beam for the simply supported lane. Okay, so it is another one problem. So we are analyzing the problem for the propped cantilever beam. So here the propped cantilever beam is nothing but one end is fixed and another end is free. So here one end is fixed and another end is free. So a propped cantilever beam the span of 5 meter. So the total span of A to B is equal to 5 meter, which is subjected to a point load of 16 kilonewton acting at a distance of 3 meter from the fixed end A. So here 3 meter with the load of 16 kilonewton. So we are considering the point C. Okay, as shown in figure. Determine the fixed end moment at A support and also finding the vertical reaction support A and B. Okay, so first we have to replace the reactions. So here the reactions are A, here the reactions is RB. So here one end is fixed and another end is free. So what are the number of reactions available for this beam? So the number of unknown reactions and moments for is 3. So here RA, RB and MA. So that is a moment. It is a fixed support. So here the rotation, it will be the created. If the load acting on this beam, it will be the rotated. So we are considering the moment at point A. So here it will be the no fixed support, only for the simply supported. Here there is no moment. So we are taking the unknown reaction for this beam 3. Next, available equilibrium equations also the 2, that is the vertical and moment if there is no horizontal force acting on this beam. So here this 2 number of unknown number of available equations, that is the equilibrium equations. Next we are going to finding the degree of static indeterminacy, that is the 3 minus 2, we are getting the 1. Now we are taking the redundant force for the RB. So here the fixed support. So it is easy way to finding the reaction for this beam and also finding the moments. So we are taking the redundant force for the left side, from the left side. So taking the redundant force for the RB. So this is for the, you know, the formula for the strain energy equation, U is equal to 1 divided by 2 EI integration of m squared into dx. So the same procedure you have to use this section also. So next we are splitted into the 2 section from the right hand side. So we are the right hand side using the RB. So that is the reactions B section. So we are the section 1 and here the section is 2. So we are considering the section 1 distance x and consider the section for the distance of here also the x. So here using the left hand side rule. So we are, if the left hand side rule we are considering, if the force acting clockwise means we are considering the negative sign. If the force acting anti-clockwise means we are considering the sign positive. Okay, so now we are applying the strain energy equation. U is equal to 1 divided by EI integration of m squared into dx. So which is equal to, here also the same 2 sections. So applying the 2 sections, 1 divided by EI integral 0 to 2. So here to here the distance is 2. So that is a 0 2 for the section m1 d squared dx plus next second section 1 divided by 2 EI integral here 2. Okay, so here 2 to here 3. So sorry 5, total distance is 5. So integral 2 to 5 m2 d squared into dx. Now we are finding the m1 value and m2 value. Okay, so for this consider this first section. So taking the moment about point B. So here the point B, it is the anti-clockwise movement. So if the force acting on the anti-clockwise movement, we are considering the positive sign. So it is a RB in the distance of x. Okay, so here if you are considering the RB value, that means a 1, that is m1 value into x. Okay, next we are taking the section 2 m2. So here the m2, for this is for the section 2. So the total distance is x, we are considering the x. So it is an anti-clockwise movement. So we are putting the RP into x. Now we are considering the 16 kilonewton. It is acting on the clockwise movement, but we are considering the clockwise movement, it is considered the negative sign. So minus 16 into x minus 2. So now we are multiple by the 2, that is a 16x into 16 into 32. So here plus into minus, here the plus. So m2 is equal to RB into x minus 16x plus 32. So we are getting the value of m1 and m2. Okay, now we are using this value for substitute the value for m1 and m2. So before going to, we are taking the by the Castigliano's theorem, we are integrate the for the partial differentiate with respect to u, sorry, with respect to a. So that is here a, but we are taking the left hand side, that is the right hand side, the right hand support is rb. Okay, so tau u divided by dou rb is equal to 0. Now we are applying this equations, dou u divided by dou rb, which is equal to 1 divided by 2i integral 0 to m1 dou m1 divided by dou rb into dx plus 1 divided by 2ei integral 2 to m2 dou m2 divided by dou rb dx is equal to 0. So again it is the integrated. If the integrated, if we are, that is the rb value, so we are considering the put the value of rb is equal to 1. So we are getting the x distance, that is dou m1 divided by dou rb. The same we are getting the m2 manual. Okay, dou m2 divided by dou rb here also is equal to x. Why we are putting the x means here put the rb value is 1. So 1 into x means x. So here there is no rb, so it is value also 0. Here there is no x, that is here also the 0. So only for this x. So 1 divided by, so we are taking this 1 divided by ei, here also 1 divided by ei. So here the 2 is cancelled. So here 1 2, here also 1 2. So we are eliminate this term, here also 2, here also 2. So the 2 term 2's are the eliminated. So only we are getting this equation 1 divided by ei integral 0 to 2 rb into x. Here m1 value for this rb into x, dou m divided by dou rb value is equal to x plus 1 divided by ei integral 2 to 5. Here m2 value is rb into x minus 16x plus 32. Here m2 divided by dou rb value is x, so which is equal to 0. So we are taking 1 divided by ei and 1 divided by for the both term, we are taking it in the outside, so it will be the 0. So that is integral 0 to 2 rb into here the x squared into dx plus integral 2 to 5, that is rb into x squared. Next 16 into x squared plus 32x into dx is equal to 0. So so simplify this equation. Now we are getting this formula, integration of x power n dx is equal to x power n plus 1 divided by n plus 1. So from this formula we can substitute this value. So taking the integration for the rb into x, here the integration of x squared x cube divided by 3. So here the limit is 0 to 2 plus rb into integration of x squared, the same x cube divided by 3. Here the limit is 2 to 5 minus 16 x squared value x cube divided by 3, the limit 5 to 2 to 5 plus 32 x squared divided by 2 2 to 5 is equal to 0. So we are simplify this equation, so we are getting the rb value. So that is the rb value is equal to 6.92 kilonewton. So from the equations we are getting the rb value, that is 6.192 kilonewton. Now we are getting the ra value and ma value. So applying the equilibrium equation for the vertical force, summation of v is equal to 0. So sum of the vertical force, here one ra, here one rb. So we know the rb value 6.912. So ra plus 6.912 minus, that is 16, it is a anti-clockwise, that is a downward direction, so put it into the minus sign. So minus 16 is equal to 0. So from this relation we are getting the ra value. Next we are finding the ma value. So if we are taking moment about point a, so if we are taking moment about point a, so if we are taking the moment about point a means it is a LH rule. So if the force acting anti-clockwise means we are considering the positive sign. If the force acting anti-clockwise sign means we are considering a positive sign. Okay, so now taking moment about point a, so it is if the taking moment about point a, it is the anti-clockwise movement. So if we are considering anti-clockwise movement, here considering the positive sign, so that is 6.91 into the total distance is 5. Next minus, it is taking moment about point A, it is a positive, but we are considering positive, we are using the negative sign. So minus 16 into the distance is 3 into here the MA. So we are considering the about point B is the anti-clockwise. So we are using the sign positive. So that is the MA, which is equal to 0. So from this relation we are getting the MA value. Now we are finding the all the reactions for the A and B and also the moment for the section A. So RA and RB. Okay, so we are put it in the all the value here, RA value, RB value and MA value. Now we are finding the shear force for this section. So shear force at point left A. So this is the A section. So this is left side. So this is the right side for the support of A. If there is no load, okay, so there is no reactions, we are considering the value of this 0. Next, shear force at just right. So here the right side. So it is upward is positive. So what is the value? 9.088 kilonewton. So this is for shear force at point A. Now we are coming to the point C. So we are taking the same right and left for the C. So we are considering the left side of the section C. So left side of the section is entire span. We have the load. It will be distributed for the 9.088 kilonewton alone. So we are taking into the 9.088 kilonewton. If you are taking the right side means here before the value. So what is the before value? 9.088 and also here 116 kilonewton. It is the downward direction, that is a minus. So that is 9.088 minus 16, which is equal to minus 6.918 kilonewton. Okay, so it is a anti-clockwise. Now we are considering the point B. So now we are considering the point B, the shear force at left at B. Okay, the B here the left side, here also right side. So the same load it will be the distributed on here the left side. So the same values minus 6.912 kilonewton. Now we are taking the right side. So right side means here the entire value and also here one the positive value. So minus 6.912 plus 6.912. So we are getting the 0 shear force at the point B. So now we are going to draw the shear force diagram for the sections. Okay, so this is for the A section. So this is for the point C. If the load is distributed to the here to here the same, here the downward direction is the anti-clockwise. So here the B also the positive direction. So it is a positive, it is a negative. So this is for the shear force diagram for this B. Okay, next we are finding the bending moment at section A and C. Okay, so now we are taking the bending moment at section A. So we are taking the bending moment at point A. So we are considering the bending moment section is here the moment is 13.44 for a mm value. So it is rotated by the anti-clockwise moment. Now we are here we are considering the clockwise moment means is the positive. If the force acting anti-clockwise means you are considering the negative sign. So if the force acting the about the point A, it will be the negative sign. So we are getting the minus 13.44 kilonewton meter. Next, bending moment at point C. So we are taking the bending moment at point C. So what is the bending moment value total? That is a force. Here the force is minus 13.44 plus here one positive directions. That is the 9.088 into distance is 3. So here to 3. So that is we are getting the 13.824 kilonewton meter. Here the bending moment at 0 for the B. So here they are simply supported if there is no moment for the section. So here the B point it will be the 0. So this is for the bending moment diagram for the section. So it is the A point we are getting the value, here getting the point C. Okay, so here we know the distance of here there is no supports. Okay, so here there is no supports, here the point of contraflexures. So here considering the x distance, but we know the distance of total distance is 5 meter. But if the section, that is the section 2, we are considering the section 2, but here we know the value of the x. So we are finding this x value. Okay, so here using the RH rule. So minus 13, that is the anti-clockwise movement. So minus 13.44 plus here one positive moment, that is a 9.088 into the distance. So from this relation we are getting the x value, that is 1.48 meter. So this is the 1.4 meter. So what is the value of this distance? That is, we are finding middle of the edge, we are considering the section 1. So this is the section 1. Okay, so this distance is x. We know the total distance for this section, so that is the 5. So 5 minus 1. We know the value of x, that is a 1.48, which is comes out to the 3.52 meter. So now we are ending this session. So thank you for watching this video. Thank you.